The concepts covered are: related angles, pairs of lines checking for parallel lines. Point, fine dot made by a sharp pencil or a geometrical figure having no length, breadth and height is called a point. Line, if we extend the two end points in either direction endlessly, we get a line. It has no definite length. Line segment, a geometrical figure obtained by joining 2 points is called a line segment. Here AB is a line segment. It has definite length. Ray, a ray is a geometrical figure which has one endpoint. P is an endpoint. Angles, an angle is formed when two rays, two lines or two line segments initiate from the same initial point. We write angle as angle ABC in first figure and angle XOY, angle ZOW, angle YOW and angle XOZ are angles in the second figure. Types of angles. Acute angle, less than 90 degree. Right angle, angle equals 90 degree. Obtuse angle, angle less than 180 degree. Straight angle, angle equals 180 degree. Reflex angle, angle less than 360 degree. Complementary and supplementary angles. Complementary angles, two angles are said to be complementary if the sum of their measures is 90 degrees, and each angle is said to be complement of each other. For example, 45 degree, 45 degree, 10 degree, 80 degree, 20 degree, 70 degree, 30 degree, 60 degree. Supplementary angles. Two angles are said to be supplementary if sum of their measures is 180 degree, and each angle is said to be supplement of each other. For example, 10 degree, 170 degree, 20 degree, 160 degree, 30 degree, 150 degree, 40 degree, 140 degree, 50 degree, 130 degree, etc. are all pairs of supplementary angles. Adjacent angles. Two angles are called adjacent angles if A. They have a common vertex, in figure, point P is common vertex. 2. They have a common arm, in figure, PB is common arm. 3. Their other arms lie on the opposite sides of the common arm, in figure, PC and PA. So, in figure, angle APB and angle BPC are adjacent angles. Linear pair. Two adjacent angles are said to form a linear pair if their non-common arms are two opposite rays. In figure, angle POQ and angle CUR form a linear pair as their non-common arms open or are two opposite rays, i.e., POR is a line. Note, A. Two linear pair angles can also be adjacent angles, but it is not necessary that two adjacent angles will be linear pair angles. B. A pair of supplementary angles forms a linear pair when placed adjacent to each other. Vertically opposite angles. When two lines intersect each other, then they form four angles. So that, angle A and angle B is pair of vertically opposite angles. Angle N and angle M is pair of vertically opposite angles. Always vertically opposite angles are equal. Pairs of lines. Intersecting lines. If two lines touch each other in such a way that there is a point in common, then these lines are called intersecting lines. That common point is called a point of intersection. In the above figure, line L and M intersect each other at point C. Transversal line. A line that intersects two or more lines at distinct points is called a transversal line. In figure, T is a transversal to lines P and Q. Angles made by a transversal. When a transversal intersects two lines, then they make 8 angles. Exterior angles. Angles which do not contain the segment of the transversal between the two lines are called exterior angles. In the diagram below, transversal L intersects lines M and N. Angle 1 and angle 4 is one pair of alternate exterior angles, and the other pair is angle 2 and angle 3. Interior angles. The angles whose arms include the line segment of the transversal between the two lines are called interior angles. Angle 3, angle 4, angle 5 and angle 6 are interior angles. Corresponding angles. When two lines are crossed by another line called the transversal, the angles in matching corners are called corresponding angles. In the above figures, angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8 are corresponding angles. Alternate interior angles. Alternate interior angles are created where a transversal crosses two parallel lines. Each pair of these angles are inside the parallel lines, and on opposite sides of the transversal. In the above figures, angle 1, angle 2, angle 3 and angle 4 are alternate interior angles. Alternate exterior angles. Alternate exterior angles are created where a transversal crosses two parallel lines. Each pair of these angles are outside the parallel lines, and on opposite sides of the transversal. In the above figures, angle 1, angle 2, angle 3 and angle 4 are alternate exterior angles. Checking for parallel lines. This is the inverse of the above properties of the transversal of parallel lines. If a transversal passes through two lines so that the pairs of corresponding angles are equal, then these two lines must be parallel. If a transversal passes through two lines and so that the pairs of alternate interior angles are equal, then these two lines must be parallel. If a transversal passes through two lines so that the pairs of interior angles on the same side of the transversal are supplementary, then these two lines must be parallel. Case 1. If AB parallel to PQ, find angle W. We have to draw a line CD parallel to AB and PQ passing through angle W. Angle QPW equals angle PWC equals 50 degree, alternate interior angles. Angle BA equals angle CWA equals 46 degree, alternate interior angles. Angle PWA equals angle PWC plus angle CWA equals 50 degree plus 46 degree equals 96 degree. Case 2. If psi parallel to QR with angle 4 equals 50 degree and angle 5 equals 45 degree, then find all the three angles of the triangle PQR. Given, psi parallel to QR. Angle 4 equals 50 degree and angle 5 equals 45 degree. To find, angle 1, angle 2 and angle 3. Calculation, angle 1 plus angle 4 plus angle 5 equals 180 degree, sum of angles making a straight angle. Angle 1 equals 180 degree minus 50 degree minus 45 degree. Angle 1 equals 85 degree. PQ is the transversal of psi and QR, so angle 4 equals angle 2, alternate interior angles between parallel lines. Angle 2 equals 50 degree. PR is also the transversal of psi and QR, so angle 5 equals angle 3, alternate interior angles between parallel lines. Angle 3 equals 45 degree.